Good afternoon. We are CS7 Group 2. Our project is hunting pattern matchings in non-station scenario time series data. For extending is the using of extended rate separately to obtain profit, mainly due to different in international trend and national policies, and because exchange rate fluctuations are repetitive and trending. Using of deep learning model to help Forex has become a major trend. Next, I will introduce some related work. The first one is time series model and the deep neural networks, which can provide good examinations of point values. The ability of deep learning is to learn abstract factors from raw data, which enable experiments to obtain good predictions accuracy. The second one is the using of CNN to predict Forex. The result shows that the model can effectively improve the accuracy of long-term predictions compared with SVR and ANN. The third one is combined models of EMD and LSTM. The combining models provide that machine learning profits better in non-linear time series predictions. According to the lecture review, we decided to conduct the follow modeling using a variety of deep learning methods to explore more possibilities. Next part.
The main objective is to predict the future price of foreign exchange by building a prediction model so that our client can use the future price data to make decisions of investing in the foreign exchange. For example, people can buy it if the exchange price is going to rise and sell it if it will decrease. For the trade companies, they can decide to input or output products based on the prediction results. To approach this goal, we also aim to find suitable model patterns and indicators by doing research and comparing the performance of them. Next page, please.
We use 3 different models to compare the predicted performance in terms of accuracy and time consuming. All these models use 5 basic features. Additionally, we added the high minus law, indicators, and patterns as additional features to increase the accuracy. The first model we use is the CNN-LSTM hybrid model, which could combine deep feature extraction and the sequence regression efficiently. The figure shows the 2 steps for this model. In the first step, we can obtain a time-dependent sequence through feature extraction by CNN, and then input them into LSTM in chronological order as the input of each time step. In the second step, successive deep feature vectors are rearranged into a series of feature sequences, and we added layers on the front end, followed by LSTM layers with convolutional residual neural network. Theoretically, the performance of deeper networks will perform better than shallow network, but in fact, as the number of layers increases to a certain number, the error rate will greatly increase due to overfitting. Residual network is a good way to deal with such problems. It extends neural networks to very deep structures by adding the shortcut connection in each residual block. The figure shows the structure of the residual block with 2 layers. The sigma represents the nonlinear function rectified units, while the predicted obtained through a shortcut and a second rectified linear unit. The figure below shows the structure we used when we building our ResNet. The last model is a gated recurrent unit model. It is a type of recurrent neural network as LSTM, which could effectively retain long-term dependencies in sequential data by using gating mechanism to control and manage the flow of information between cells. As we can see, there are 2 gates in the model. Reset gate determines how to combine new inputs to previous memory, and update gate determines how much of the previous state to keep. These gates in the GRU are trained to selectively filter out any irrelevant information while keeping what is useful. Unlike LSTM have 2 different states passed between the cells, GRU only have 1 hidden state transfer between time steps, which is able to hold both the long-term and short-term dependency at the same time. This structure of GRU allows it to adaptively capture dependencies from large sequence of data without discarding information from earlier parts of the sequence. To improve the performance of our models, we added financial indicators and patterns as additional features. We tried 2 types of moving average indicators and 2 types of momentum indicators. After repeated tests, we found that the momentum index decreases the performance, while the moving average increased the performance. And we found exponential moving average slightly performed better. This is because the exponential moving average gives more weighting or importance to recent price data. Double top and bottom are 2 important and basic technical analysis patterns used by traders. Double top indicates a bearish reversal in trend as selling signal, while double bottom is a signal for bullish price movement. We combine these 2 patterns by adding additional features into our models, which could effectively improve performance in terms of the accuracy.
Now let's look at the results. The 3 evaluation metrics we use are mean square error, mean absolute percentage error, and the mean directional accuracy. The questions on the top right of this slide shows how each metric is calculated. MSE and MAPE main focus on the value difference between prediction value and the ground truth value. But these 2 metrics do not stand for the trending march, do not have the function to measure is the price going up or going down in the next time period accurately predicted. MDA's evaluation metric has this function. It compares the predicted upward and downward to the real trend. Gives the probability the upward and downward are predicted correctly by the model. The table in the lower part of this slide shows the highest accuracy of different models after many runs. The results are obtained using the same data, Australian dollar to American dollar, and the time step between each data sample is 15 minutes. Also, the train set and the test set size are same for all 3 models. First, look at the MSE score. CNN-LSTM model has an error rate at 0.06% and is higher than the other 2 ResNet and GRU, which have error rate around 0.01%. As far as MSE is concerned, ResNet and GRU model perform better. When it comes to MAPE, the results reveal the performance of CNN-LSTM model and the ResNet are close, while GRU is the best, which have an error rate as 0.0005%. Since the fluctuation trend is the point we want to focus on in the real market, more attention should be paid to MDA. CNN-LSTM model have an accuracy at 43.27%, while ResNet is at 43.74%, which is slightly higher. The result for GRU model is almost 100%, which is almost impossible, and we're still trying to figure out the problem. Based on the MDA result, our group thinks ResNet model is the one performed better for this project. Now let's look at this figure. This figure is the prediction result using ResNet model. X-axis represents the data sample and the y-axis is the currency exchange rate. The blue line represents ground truth value, while orange line is the prediction. From the figure, it can be seen that the predicted trend is basically consistent with the real trend, and the error between prediction and ground truth is small at most time. But when the exchange rate reaches the bottom, the error is much larger than other times.
The current best performing model is the model added double top, double bottom, and the EMA indicator. So if want to continue to improve the prediction accuracy, we can add more additional features. Now the model looks like normal and have the best performance is the ResNet model. We use the chain that has 9,000 data and the test set has 3,000 data to run. When only basic input features are used, the accuracy of MDA is 39.13%, and when only add the pattern, is 41.37%, and then when add the pattern and the EMA are 43.74%. The figure below is the result of using pre-trained model made by AUD/USD 15 minutes to test 1,000 samples of EOR AUD 15 minutes. And we can see the MDA is higher again, even over 50%, which means that the model is well trained and has the well generalization.
In conclusion, we built 3 models, CNN-LSTM, ResNet, and the GRU model. We add the pattern double top and double bottom, and the indicator EMA in the models to predict the highest and the lowest price. We use MSE, MAPE, and MDA to evaluate the performance of the models. The accuracy of MDA shows that GRU has the highest accuracy. However, the results is too high, so we are still trying to find the reasons. During the process of the project, we compared 4 patterns and 5 indicators and selected 3 of them. In the future, we suggest other people can try to test and compare more patterns and indicators. Because there are dozens of them, we only focused on a few of them due to limited time. So it is a limitation of this project. Also, these 3 models are selected based on our research about 5 models. There are more models and evaluation methods which can be used and compared to have more complete and credible results. We didn't compare many models and methods, which is another limitation of this project. And of course, the unexpected results also need to be fixed in the future. And this is our presentation. Thank you for watching.